Hi again. So exponential transformations, they're just like quadratic transformations. Exactly, except for one very key thing. We knew quadratic functions as, or the parent function as f of x equals x squared. That's a quadratic, right? That's the base or the parent function. Quadratic parent function. All other quadratic functions comes from that. That's why we call it the parent. But with exponential functions, you know that the x, or now you know that the x has to be in the exponent. But what is before it? Clearly not a question mark. These are called base functions. 2 to the x, 3 to the x, 1/2 to the x, 4 to the x, 0.257 to the x. All of these are base functions. And you're like, well, what does that even mean? Well, the idea is if there is an exponential function, it has to start from something. But because we can't have x to the x, because that doesn't work, right? Or y to the x, because that doesn't work either, we need to have a number in front. So the base of an exponential function is the number directly in front of the exponent. It is not a part of transformations. It is just its base. It's where it starts from. Let's do a couple of examples. Let's say I have -3 times 2 to the 1/2 x minus 4 plus 7 function. What's the base here? Well, it's the number directly below, or the base of the exponent. This is the base. The 2 has nothing to do with the transformation. So let's just go around the clock here and we know what's going on. Negative in the front means x-axis reflection. A 3 in the front means a vertical stretch of 3. A 1/2 in front of the x inside parentheses, or in this case, in the exponent. That is a horizontal stretch of 2. Right? The same rules apply. The -4 is right 4, and the +7 is up 7. Exactly the same as you would see in a quadratic transformation. The only difference is the 2 there is its base. Now, you might be asking yourself, well, Mr. Dramas, why did you have to put the multiplication sign in between these two things? Well, there's a really easy answer for that. Let's say, take the same exact thing, and let's say I simplified that through multiplication. I can't do that. I can't do that because PEMDAS says I can't. Because remember in PEMDAS it says parentheses first, then exponents. So mathematically, I am not allowed to do -3 times 2 and then raise it to the power. The 2 doesn't belong to the -3. It belongs to this crap up here. So I can't do that. But let's just say, yeah, let's just play around with this. Let's say it was -6 to the 1/2 x minus 4 power plus 7. Okay. Ha ha ha. We're playing your little game. Well, what if I told you that 6 was not the base of this function? Meaning there was some kind of a vertical stretch or shrink that happened before it. You would say, I have no idea what that transformation was. Because was it a -3? Was it a -12? Because a -3 would imply that that was a 2, meaning there was a vertical stretch. Well, what if I said that it was a -12 before? That means that there was a 2 there, which means that there is a vertical shrink of 1/2. My point is, if I don't put the multiplication sign and a number in front that signifies a vertical stretch shrink, you would have no idea how it got to simplify as that. So this is the answer. This is the regular way to do this. Let's do another one. F of x equals 1/2 times 4 -3x plus 2 plus 1. All right. Well, what are the transformations that occurred here? They're pretty simple. You know that 4 is the base because it's the number right below where the exponent lies. This is a vertical shrink of 1/2. Truth teller. This is a y-axis reflection. This is a horizontal shrink of 1/3. This is left 2, and this is up 1. Easy.